So as we went through the warm-up today in P5 Part 3, I took you through a process. That process quite often is the process you folks use to find a least common denominator. So we're not moving into the next portions of the chapter just yet. The focus of today's lesson is just finding a common denominator. So real quick, why do we need a common denominator? Or more importantly, when do we need a common denominator? Yes. So think back to what we did. What you just took a quiz on yesterday. You simplified, multiplied, and divided rational expressions. You did a nice job with it too. Your grades are in power schools. So you simplified, multiplied, and divided your rational expressions. What do we have to do next? We have to add and subtract them. Fun fact, this lesson is going to go so badly. Those next couple lessons are going to go so badly if we can't get this down. So today's lesson and last night's homework and tonight's homework, super important building blocks to your success in the rest of this course. So today we really have to get it. Like, this is not something you'd be like, I'll get it later. No, and I feel bad for kids that are absent today. If today doesn't go the way it needs to go, the rest of this course is excruciatingly challenging. So, without any further ado, let me introduce you to what you might actually think at the end of the day is maybe even an easier way to come up with a least common multiple or a least common denominator. You know, I kind of use those things as synonyms. So, a least common multiple is the same, in essence, as finding your least common denominator. Again, its definition is just, it's defined as being the smallest. So I'm right here right now. It's defined as being the smallest of two common or similar multiples of two numbers, terms, or, as we're going to work on, expressions. Okay, so the throwback I'm going to ask you to think about with regard to finding the LCM or LCD is this thing called a factor tree. Do you remember making factor trees? Like if we had to make a factor tree for 12. Do you remember doing that? Yeah. So like the first thing you had to do was just think of any old number that goes evenly into 12. Little help. I need a number that goes into 12. Royce. 4. 4 goes into 12 3 times. So that's an amazing first branch to our factor tree. I really like it. Any number that still had factors, you had to actually keep going on, right? So 3, that's what we call prime. Prime numbers are items only divisible by 1 in themselves, right? So 3 is prime because it doesn't have any other factors besides 1 and 3. I see Olivia holding up some fingers for me, telling me that 4 factors again to be 2 times 2. So your teachers might have taught this as a factor tree, but fun fact, the big kids call it the prime factorization of a number. So the prime factorization of 12 is 3 times 2 times 2. So 3 times 2 times 2 is 12 completely factored. It can factor no further. 3 is prime. 2 is actually our only even prime number. So this is 12 completely broken down into its prime factors. Okay, now, what's up?
What's the importance of it?
You're about to find out. Patience, young Padawan. All right, so 8. I now need to make a factor tree for 8. I need a number that goes into 8. 4. Yeah, 4 times 2 would give me 8. And then 2 is prime, so that's done. 4 is going to factor again, just like it did before, into 2 times 2. So the prime factorization of 8, if we break it all the way down into its prime numbers, 8 becomes 2 times 2 times 2. What I'm teaching you is the algorithm the step-by-step process for doing this when I have to do it with polynomials. What is step one in every problem we're going to do today? Factor it until we have prime factors for our polynomials. Right now, I just completely factored 12 and I completely factored 8. They are products of prime numbers now at this point. What's up, Olivia?
Can you just make it 3
Oh, go ahead.
to the second power?
Okay.
I mean,
So what I hear you wanting to do right now is move from the prime factorization to actually the LCM. Remember, we already answered the question from the warm-up. The answer to the question is 24. You did that in the warm-up, right? So how are we using our prime factorization to support this answer of 24? So if I want to now find the LCM using your prime factorization, here's what I'm going to do. I'm going to grab all of these factors from the left side, the ones in red, and I'm going to write them down. Automatically, they're going to get to be a part of my LCM. So 3 times 2 times 2 is going to be a part of my LCM or my LCD. Notice I already wrote down 2 2's. That means that I can get rid of 2 of these 2's. I wrote them already. If I don't get rid of them, I'm not identifying the least common multiple. I'm just identifying a common multiple. The idea is that I just need to write the factors of 8 that I didn't include yet in my LCM. So the only factor that's actually missing, I just need one more 2. So if I multiply 3 times 2, I get 6. Times 2, I get 12. Times 2, I get 24. I got my answer. So another way of finding a common multiple, and I think this is really handy, especially if your numbers are really big, is to do the prime factorization, factor whatever that number is, and then just identify the factors. Well, first of all, let me back that up for a second. So I took it down to its prime factorization. I brought over everything I wrote down first and then just inserted any factors that were missing from that second value. This is the technique we're actually going to use today because we have polynomials to deal with. So our step-by-step process for doing this with polynomials is just like the way I showed you with the numbers. Step 1, we factor, again, like the first step in literally every problem in this chapter is to factor, which is why if you can't factor, you are toast in this chapter. So we factor each polynomial completely, and then you compare the individual factors of each polynomial, bring down what's on the left, and insert any that are missing from the right to produce your LCM or LCD. So what I just did with numbers, I'm about to do with letters. All right, giddy up, kids. Let's do it. So step 1, I write everything out in terms of its factors. So step 1 on example 1, x minus 1, that's prime. It's done. It's like having a 5 there. Like you can't break x minus 1 down anymore. If I were going to write x minus 1 cubed as a product of factors, that's just x minus 1 times x minus 1 times x minus 1. So step 1 is to write everything out in terms of its factors. Step 2, I always grab what's on the left. So winner, winner, chicken dinner, that's going to be a part of my answer. X minus 1 is going to be in there. I already have part of my answer correct. And I just need to insert the factors from the right, in this case in red, that are missing. So notice I already wrote down one of the x minus 1s. There's already one there. So I just got to ask myself, what am I missing to get back to this? Well, if I wrote down one of them already, I just need 2 more. So it's x minus 1 to the 3rd power. That is the LCM or LCD. If we were adding fractions where these were the denominators, then I'll let you know that x minus 1 cubed would be your common denominator. This one's real similar to like finding the LCM between 25 and 50. The LCM of 25 and 50 is 50. So that happens every once in a while where your LCM is actually one of the values in the original problem. Example 2. This one not quite so friendly because not everything is factored. So I'm going to go ahead and factor everything. That is step 1. Factors of -2. So factors of that -2, that would give me 1 in between. So factors of -2 that make 1. I think that's just +2 and -1, right? And then things that multiply to give you x squared are just your x and your x. So if I FOILed that, I would have x squared minus 1x plus 2x, which is plus 1x, and then +2 times -1 is -2. So that's done. X minus 1 squared. That's x minus 1 times x minus 1. Any questions on step 1? All good? All right, nice job. Looks good. All right, so the next step is I bring down what's on the left. So winner, winner, chicken dinner. X plus 2, x minus 1 gets to be in my answer. And then I use my eyeballs to compare what I have written, x plus 2, x minus 1, to the factors that are in that second quantity. And I have to ask myself what's missing. Anybody know? Take a guess. Little intellectual risk taking. Go ahead, Mason. It is an x minus 1. Yeah, I had one of them written down already. One of them's written right here. So I only need one more. There's only one more missing. Yeah, and then, you know, the big kids would write that as x plus 2 times x minus 1 squared. So that is your LCM or LCD for the original problem. You okay, Royce? I'm reading the nonverbals in the room. The eyebrows up. Okay. All right, let's do it again. Okay, in example 3, again, the first step is to just write everything out in terms of its factors. So we got x minus 1 squared is just x minus 1, and then you have x plus 1. That second set of parentheses there, this bit right here, if I want to write that out the long way, that's just 4, x minus 1, and then we got x plus 1 times x plus 1 times x plus 1. I'll bring down what's on the left. So that starts as, I got 2 x minus 1s and an x plus 1. So I have 2 x minus 1s, which means I don't need that. But I only have 1 x plus 1. So I can only get rid of 1 x plus 1 up here. My last job is to insert those missing factors into my answer, which means I have to bring down my 4 and an x plus 1 and an x plus 1. But that looks like some chaos right there, so I am going to tidy that up a little bit. Wouldn't want to leave that as a final answer. But before I clean this up a little bit, does anybody have any questions on why I only brought down 1 of the x plus, or 2 of the x plus 1s, or why there's a 4 there, or anything like that?
Well, what happened to the x?
Oh,
Oh.
my stylus
Oh,
glitched.
is that a dollar answer?
It's a dum-dum,
Oh, I forgot.
because I was a dum-dum. My stylus doesn't always, like, I don't know, I think I left a space there. I'm wondering if I wrote it and then just didn't write it. Excuses.
Wow.
I made an excuse. You can have excuses, or you can have success, but you cannot have both. You cannot have success, and you get dum-dum. All right.
Alex.
Oh, don't throw it. You poke out an eye. And then, like, Mason's mom will be, like, all angry at me because he got stabbed in the eye with a dum-dum stick.
So would that be 4x, x minus 1 squared, x plus 1 to the third?
It would be, indeed. This is what we call progress, friends. Yeah, so you just tidy up your answer there at the end.
I feel like these are pretty straightforward just because you can look at the problem and then see what's missing. And if it's missing, just put it in the answer.
I hope it's...
Like, put the 4 and the x together.
Yeah, routinely. Would it be wrong if you didn't? No. Alrighty.
Is it mud, Alex?
We got one left.
Is it mud?
It's out of this last example. I'm hoping to give you, how do I put this? A shortcut. If you grab onto the shortcut, if your brain allows it, that's awesome. You can use it. If you're not quite seeing it yet, I'm going to have you try a couple more and see if then your brain grabs onto it a little bit. But these particular polynomials they're kind of factored already, but I always I don't know. I'm going to write x cubed out as x times x times x. Remember, anytime we deal with exponents, there's always a long cut. And then x to the fourth is x times x times x times x. You bring down what's on the left. So if I'm writing my LCM or LCD, I got to do x times x times x. And then I just have to insert what's missing. So what's missing? Good, Royce? Yeah, because I have 3 of them written down already. I only need 1 more. Notice my answer is x to the 4th. So that is your LCM. All right. You have 1 independent practice problem to go ahead and take care of, and then we can talk about a shortcut. Remember, step 1 is to factor completely, and then step 2, bring down what's on the left, insert factors that are missing from the right. So again, like going back to, Matt and I were talking about how to factor 4x squared minus 1. It's just a difference of 2 perfect squares, so you square root the 4x squared. Let me make this bigger. It looks small, sorry. So you square root 4x squared. The square root of 4x squared is 2x. And then you square root 1, that's 1. And then because it's a difference of 2 perfect squares, you need different symbols in your parentheses. You need a plus and a minus. 2x squared plus 5x plus 2, you would AC group. So if you needed some scratch work there, maybe you did 2 times 2, that's 4. Factors of 4 that are going to give me my 5x. It would be like, what, 1x and 4x. And then you bring down your 2x squared and your 2. Swoop it and group it.
2x squared plus 5x plus 2,
Mm-hmm.
I just looked it up.
That's good. That's all good. I like your thinking.
Because I did it last night, and that's what I was confused about.
Oh. All right. So you guys have factored before. I'm not as concerned about that. I am concerned about what's hiding behind that gray box.
Easy.
What do you think, Alex?
I think is the conclusion question.
Yeah.
No. What's the answer to this? The independent, the IP. What'd you get?
I will tell you in a moment.
Oh, okay.
I got,
I'm waiting.
Sorry, I had to reopen my...
You're totally fine, sir. Thank you for participating.
So, I think I had a little trouble with factoring. But I had 4x, and then I didn't get anywhere from there.
So it's already, do you see how I factored it already? I got 2x plus 1, 2x minus 1. And then the second quantity factored to be 2x plus 1, x plus 2. Let's take it from there. What automatically gets to be part of my answer?
2x plus 1.
And
X plus 2.
we always bring down what's on the left. So it'll be 2x plus 1, 2x minus 1. Automatically, that blue chunk is going to appear in my answer.
Yeah. Wait, no, you actually don't include that.
So that's in my answer, but notice there's still something hiding behind the box. So you always bring down the factors there that you write down first. Okay, then you look at the red bit. And you have to just write down anything you didn't write down yet.
X plus 2.
Yeah, you got it. Does that make sense? Sweet. So the answer to this independent practice is 2x plus 1, 2x minus 1, and x plus 2.
It wouldn't be 2x plus 1 squared,
No, it would not be, because one is 2x plus 1, the other one's 2x minus 1.
but the red answer. It's gotta be 2x plus 1 plus 2x plus 1. It's gotta be two 2x plus 1s in the red side for it to be 2x plus 1.
Yes. Sorry, I was not jumping on your train there initially, but yes, that would be right. Okay. So the conclusion question, always very important to consider. When factors with like bases appear in the problem, what shortcut could you take? Do you remember in the previous problem we had x to the third versus x to the fourth? Our answer was x to the fourth. What shortcut could you take? Tyler knows. Yeah, choose the factor with the highest power. You put it pretty simply. I'm stealing it. Nice job. So that's the answer to your conclusion question, and that's a shortcut if you see it.
So we have the last 10 minutes of class.
We are going to get more practice in, so we're going to meander on into our homework assignment.